Think about it right now. Where is everyone? It's a question humanity has been asking since the very first time we realized those little pinpricks of light in the sky were actually entire solar systems, burning suns, just like our own. The universe is unbelievably, mind-bogglingly big. It's almost 13.8 billion years old. Our own Milky Way galaxy has at least 100 billion stars, and nearly every single one of them has planets orbiting it. 100 billion. Imagine, just for a moment, how many potential homes, how many possibilities, how many chances for life to spark, and how many opportunities for us to find them. And yet, in the 60 years we've been listening, looking, sending out signals, we've heard absolutely nothing. Just an eerie, echoing silence. The Fermi Paradox. This isn't just a regular mystery, it's a full-on cosmic head-scratcher known as the Fermi Paradox. Enrico Fermi, a brilliant physicist, once looked up from his lunch and asked, simple as anything, "Where is everybody?" And that's exactly what our curious crew decided to investigate. They piled into their imaginary spaceship, armed with questions and a whole lot of curiosity. And what they discovered was unsettling, thought-provoking, and downright jaw-dropping. So, buckle up. Why is it so quiet out there? Life is incredibly rare. The first possibility, and maybe the most uncomfortable one, is that, well, life, especially intelligent life, is just incredibly, impossibly rare. Our curious, adventurous boy was immediately skeptical. But there are so many planets. Surely one of them has, space penguins or something. And he has a point. The numbers are astronomically in favor of life existing. Billions of Earth-like worlds out there. But, and this is where our enthusiastic analytical girl steps in, we don't know how life actually starts. We know how it evolves, sure. But that initial spark? The moment where non-living chemicals somehow figure out how to self-replicate and become something alive? We have no idea. This is the abiogenesis problem. Maybe it's not a common chemical reaction. Maybe it's not a natural outcome of planetary chemistry. Maybe it's a fluke. A 1 in a trillion shot. And if it is that rare, then maybe Earth is truly special. Maybe we are the only ones. The first, or the last, or just incredibly, incredibly lucky. But that felt too lonely. The crew wanted a different answer. The Great Filter. What if life is common, but something always, always gets in the way? Enter the concept of the Great Filter. This idea is both fascinating and terrifying. It suggests that there's some insurmountable challenge, some universal hurdle, that almost no civilization manages to jump. A point where civilizations either fail to start, fail to advance, or just plain destruct. Think about it. We know that for billions of years, life on Earth was just tiny, microscopic things. It took forever for complex life to show up. Then, it took even longer for intelligent, tool-using life to emerge. Maybe that's the filter. Maybe complex life is the rare part. Most planets might only ever harbor bacteria. Or maybe the filter is ahead of us. This is the part that gave our analytical girl pause. If life is common, but advanced civilizations are not, it means something wipes them out. It could be cosmic disasters, like supernovas sterilizing entire solar systems, but it could also be self-destruction. Nuclear war, uncontrolled artificial intelligence, a catastrophic climate event they couldn't fix. Or maybe, just maybe, they invent technology so powerful and dangerous that any civilization that develops it inevitably brings about its own end. The thought that we might have already passed the hardest filter, that would be incredibly reassuring. It means the rest of the galaxy is ours to explore. But the idea that the filter is ahead of us, that we might be destined to hit a wall that has stopped everyone else, that is truly sobering. It forces us to ask, can we be the ones to make it? Why we don't see them. Now, our clever observant cat had a different perspective entirely. He might just be licking his paw, looking out at the stars and thinking, the problem isn't that they aren't there, it's that we aren't looking properly. And he's got a very good point. We've been listening for only 6 decades. 6 decades compared to the 13.8 billion years the universe has been around. That's like less than a cosmic blink. In that short time, we've only looked at a tiny, tiny fraction of the stars in our galaxy, mostly with radio and optical telescopes. But are those even the right kind of signals? An advanced alien civilization might have moved way beyond radio waves. Maybe they use lasers, neutrinos, or something we haven't even dreamed of yet. We're listening for whispers with a butterfly net when they might be communicating using telepathy or broadcasting their whole internet over gravitational waves. It's also entirely possible they sent out signals millions of years ago when Earth was just a muddy ball, and their messages are already long gone. Or maybe they are broadcasting, but we're just too low-tech to recognize the signal. The question of how to find them, not if they exist, is itself a huge challenge. What if they're hiding? But what if they are here, and we just don't notice? This is where the possibilities start to get truly mind-bending. Our crew stumbled upon a whole collection of ideas suggesting that the galaxy isn't quiet because it's empty, but because it's hiding. Think about the zoo hypothesis. The idea is that advanced civilizations are aware of us, but they have a strict rule, a prime directive, if you will, to not interfere, to let us develop naturally, without our primitive minds being utterly broken by their presence. We're in a cosmic nature preserve. They might be watching us right now, analyzing our data, scratching their metaphorical heads, but keeping themselves hidden until we're ready. Which raises the awkward question, when will that be? Or maybe the quiet isn't a result of politeness, but of fear. The dark forest theory suggests that the universe is a dangerous place, a dark, terrifying forest where every single advanced civilization hides, because the moment someone makes their presence known, they become a potential threat to everyone else. The best survival strategy in this scenario is to be perfectly, absolutely silent. The one who breaks the silence is the one who gets eliminated. If that's true, our early attempts at broadcasting signals into space might have been a monumental mistake. We might have just been waving a "we are here, please don't blow us up" sign. This entire investigation left our curious crew with more questions than answers. The cosmic mystery. Is the silence comforting because it means we might be unique and important? Is it terrifying because it implies a universal threat that lies ahead of us? Or is it simply a sign of our own limitations, our own smallness in an ancient and vast cosmos? The biggest lesson our crew learned is that we are just at the very, very beginning of this journey. We've barely dipped our toes into the vast, dark ocean of the universe. We don't have enough data to say for sure. But the fact that we're asking the question at all, that's what's truly significant. The Fermi Paradox is a mirror that makes us look at ourselves, at our planet, at our history, and forces us to consider our future. Maybe one day, our own analytical, curious minds will be the ones to crack the code. Maybe we'll find a signal, or a derelict spacecraft, or just a subtle anomaly in the starlight of a distant sun that cannot be explained. Until then, the cosmic silence continues, a quiet, echoing challenge to keep looking, keep questioning, and keep wondering. Because maybe, just maybe, The only thing more amazing than being completely alone in the universe is discovering that we never were. Thanks for joining us for this investigation. Keep your eyes on the stars and stay curious. If you like our content, don't forget to like and subscribe. Until next time.